Alright, so let's recall what we had done in the previous class. In the previous class, we had solved a system of equations, and the idea there was that from system of equation we went to a matrix, augmented matrix. We looked at just the coefficient matrix part and then tried to write A, because we took it as a square matrix. So, what we did was that we had a square matrix A, which was n cross n, and for certain examples we were able to write A as LU, where L was lower triangular and U was upper triangular. Fine, this is what the idea was. We wanted to write A as LU, L for lower triangular, U for upper triangular. Fine. And in the two examples that we saw, we could do it. Now, if you recall what exactly the idea was, that given any matrix A, all right, I needed that this entry should be a pivot. All right. I wanted this to be a pivot. Using this pivot, at the next stage, I could make, so this is a non-zero entry which is a pivot for me. At the next stage, I could make this entry 0, all right, the 2 1 entry 0. I can again use this pivot to make this entry 0. So, every entry of this column other than the 1 1 entry can be made 0, all right. And then I had some things here that I was not bothered about. The idea was that I had a pivot here which was used to make every other entry in that column to be 0, all right. So, pivot was used to make every other entry below the pivot as 0. Fine. Once it was done, we went to the second row, all right, and then we looked at a pivot here, again a pivot here. We wanted another pivot. Once we had this pivot, then we can go to the next stage. So, I have a pivot here, I have another pivot here, every entry is 0, again every entry is 0 here. What happens at the top was immaterial for us, all right. So, the idea was that I needed a pivot at 1 1 place. So, needed a pivot at 1 1 place in A, needed a pivot at 2 2 place in A tilde, not A, that is important, not A. And what is A tilde? A tilde is a matrix. So, A tilde is a matrix in which the first entry, in which the 2 1 entry is 0, all right. So, what I am saying is that this entry is 0, is that okay? That is important for me, all right. At the next stage, what I will require is that if I want to proceed further with a pivot, I will need a pivot here, all right. So, need a pivot here, or we can think of this as a new matrix for me and then again a start here, all right. So, I have another matrix, I need the pivot at the 1 1 entry of this new matrix as we had at the previous stages. So, the question is what condition do we require as such, fine. So, let us look at this. So, at this stage, at the first stage we needed that. So, first stage, so this part tells me that I needed A 1 1 to be non-zero, this was the need, all right. Now let us look at, if I want to make this as a pivot in A tilde, what exactly do I require? All right. So let us do the simplification for ourselves for a 3 by 3 matrix and proceed. So I start with the matrix which is 3 by 3, say A, B, C, D, E, F. All right. And I am not bothered about this part for the time being, or let me write it. I think we will require it E, F, G, H and I. All right. So I am assuming that A is not 0. So this is a pivot for me. A is not 0. All right. Then what do? We leave it the first row as it is, no change. Then I have to make this 0. To make this entry 0, what do I need? I need to multiply the first equation. So I have to just look at d upon A of ABC, add it to DEF. What do I get? Minus d upon A into A is 0 plus this. So this part is 0. Now this part will become D minus BD upon A. This will become F minus CD upon A. Fine. So this is the entry that I needed for me. So I would like you to see that this entry is nothing but I can take 1 upon A common, AE minus BD. And what is AE minus BD? Can I say that this is nothing but the determinant of the matrix A, B, D, E? All right. So look at the determinant of this AE minus BD, which is the inside entry here. All right. So what I need is that this entry determinant of this should be non-zero if I want a pivot at the second place. Is that okay? So earlier I wanted pivot for A11 to be non-zero, the first entry should be non-zero. Now I want that the 2 by 2 matrix that I have here, 2 cross 2 matrix of A that I am looking at. So it is A11 here, A12, A21, A22. So I want that A11, A22 minus A12, A21 is, this should be non-zero. Or determinant of the first block here, determinant of this should be non-zero. Is that okay? Now let us go back. If I want the third one, what is the requirement that I need? All right. So let me make this also 0. So I have got 0 here. Using a similar trick that I am done earlier, I want to get rid of this G. This is what I have done, G. So this will become H minus. So I have to multiply by minus G upon A to ABC and then add GHI. I hope I am correct. So A and A cancels out, I get minus G plus G is 0. I get H minus BG upon A and I get I minus CG upon A. This is the matrix I get. Fine. So let us take this matrix that I have here and write it at the next place. So is there a, so what I had was, let me write it again, A, B, C, 0 here, 0 here. Here I had E minus BD upon A, E minus BD upon A, E minus BD upon A. All right. Then it was EF, F minus CD upon A, I think, F minus CD upon A, H minus BG upon A, H minus BG upon A, I minus CG upon A. This is the matrix I had. We have already assumed AE minus BD is not equal to 0 and therefore this is a pivot for me and I want to make this entry 0. So if I want to make this entry 0, I will have A here, B here, C here, 0, 1 upon A times EA minus BD and this entry is 1 upon A times AF minus CD, 0 here, 0 here. So, I need to multiply this equation, the second equation, by the second row by H minus Bg upon A to 0 E minus Bd upon A, F minus Cd upon A, and divide it by E minus Bd upon A, so that this and this cancels out, I get this. So, I have to do this, fine, and minus of this I have to do because I have to cancel it out. So, minus of this plus 0 H minus Bg upon A, I minus Cg upon A. This is the matrix I have to look at. So, I get 0 minus 0 as 0. If I look at here, it is H minus Bg upon A. This and this cancels out, all right. So, this will cancel out to this one. I will get minus H times Bg upon A, and H minus Bg upon A, that will cancel out, I will get 0, fine. The last one entry, this entry will be nothing but, I already have I minus Cg upon A, fine, minus H minus Bg upon A times F minus Cd upon A divided by E minus Bd upon A, all right. So, let us solve it out. So, I can take out this part common throughout, and I do not have to worry about, just look at the inside part, what the inside part is. So, the inside part is E times I minus Ceg upon A, fine, minus Bdi upon A, minus minus plus Bc dg upon A square, this, minus Fh minus Cdh upon A minus Bfg upon A minus minus plus Bcdg upon A square, fine. So, this is the one that is, I have taken out this part common and then looking at things. So, look at here, Bcdg upon A square, and this cancels out, and I take out 1 upon A common here again. What I am left out with, AEI, fine, minus CEG minus BDI minus AFH plus CDH plus BFG. Now, question is, what is this inside? So, let us look at the matrix. It was ABC, DEF, GHI. Let us look at the determinant of this. Determinant of this is nothing but AEI, which is here, then minus AFH, AFH with a minus sign, AFH with a minus sign, fine. Then we have with respect to B, BDI here, BDI with a minus sign, BDI with a minus sign here, then BFG with a plus sign, BFG with a plus sign here, which is a plus sign. Similarly, CDH with a plus sign, CDH with a plus sign here, all right. And the last one, which is CEG with a minus sign, I have got this. So, what I need is that this part should be 0. So, let us go back to the previous slide, and then what we are saying is, in the previous slide, this part, the 3 cross 3 determinant should be non-zero, all right. So, what we are saying is that if I have a matrix, so what we are saying here is finally is that I have a matrix A which has the property that A11 entry is non-zero, fine. Then look at this matrix A11, A12, A21, A22, determinant of this has to be non-zero. At the next stage, determinant of A11, A12, A13, A21, A22, A23, A31, A32, A33, determinant of this is not equal to 0, and so on. If I have such a thing, then at each stage I will have a pivot, fine, and this pivot will help us to make, this pivot will make every entry 0 here. I will have another pivot here which will make every entry 0 here, and so on. So, I will get this matrix as everything here is 0. So, I get this as a upper triangular matrix. I will get it as upper triangular matrix, fine. So, what exactly we have done? So, I have A here, and on the left multiplied by certain matrices. Now, what were these certain matrices? All right. So, I have got the upper triangular matrix. The idea was to get A equal to LU. I have got U, which is upper triangular. So, what at present I have got is, I have got some matrix P here. I do not know what this P is, whether it is lower triangular or not, but I have got P times A as U. I need to understand what is this P, need to understand this. So, in the previous examples, what we have seen is that if I want to make these entries zeros here, I need to look at the rows of the identity matrix and then do certain manipulation to it. What exactly we are doing is, at the first stage, if I look at first stage, or making the first column entry 0, if I want first column entries 0, what I need is, I need to use the first row of the identity matrix, all right. I want to use this, and then look at the second row of identity, the third row of identity, and so on, and then make them 0. So, what exactly we are saying is that the matrices that we are going to have is 1 here, 0 here, there will be something here, 1 here, this is the first one as per the second row is concerned. At this stage it will be 1, 0, again 0, fine. Second row we are not going to do anything here at this stage, because that is already been made 0. At the third stage I would like to make something using this one, fine. This is again identity for me. So, when I look at these matrices, these are lower triangular matrices, all right. So, therefore, to go from first stage to second stage, in which all of these entries have become 0, all right, I just need to multiply by a lower triangular matrix, fine. Once I have done that lower triangular matrix, I have a matrix of this type, where the first row is as it is, but every entry in the first column is 0, fine. I can use induction, or you can use the same idea to say that I can start with this matrix now, fine. This entry is non-zero, and hence I will get a lower triangular matrix, such that this matrix, the new matrix that I am looking at, all right, the lower part has this form which is lower triangular, and so on, fine. So, what we know is that since product of lower triangular matrices is lower triangular, the final matrix will be lower triangular, the final matrix is lower triangular, all right. Or if you want to look at from the induction point of view, what I had was, I had A, I had some matrix L1 say, all right. So, this L1 was product of lower triangular such that this looked like a star here, 0 here, 0, and this is my A tilde, and in A tilde of 1 1 is non-zero, the 1 1 entry of A tilde is non-zero, fine. So, I can use induction to get say L tilde of A tilde to be is equal to U tilde upper triangular. Fine. So, I want to club the two together to understand the final thing. So, let us look at this matrix 1 0 0 L tilde times L1 of A. Fine. I want to compute this matrix product. So, this will be equal to 1 0 0 L tilde times a star 0 star A tilde. So, this is what I am saying, that if you understood matrix product, everything becomes nice. So, this is nothing but just the first row remains as it is, no change. 0 times this will be 0, so you will get 0 here, and this is nothing but L tilde A tilde, and therefore, you get here a star 0 and U tilde, which is an upper triangular. Fine. So, you get an upper triangular matrix that you can see here overall. Now, we need to understand that can I write this in a nice way, all right. Is this a lower triangular matrix, all right. So, what we know is that L1 is already lower triangular. Now, this matrix L tilde is lower triangular, L tilde is lower triangular. By the induction hypothesis, by induction. All right. So, since L tilde is lower triangular, this matrix is also lower triangular. And hence, with the first idea that product of lower triangular is lower triangular, I get that this is lower triangular. So, I can write this matrix as a P tilde, which is lower triangular. So, I get that P tilde times A is equal to U. Let me write this as U itself here, and therefore, A is equal to P tilde inverse U. I write it as L, so it is LU. Now, question is, if L is lower triangular, can I say L inverse is lower triangular? Why am I saying this? Because if you note here, this matrix P tilde that we wrote here, P tilde here is lower triangular. Fine. So, since I know that P tilde is lower triangular and inverse of a lower triangular matrix is also lower triangular, that also we had seen in some of in the previous lecture, or just try to prove yourself that if something is lower triangular, its inverse is also lower triangular. You get that you can write A in terms of a lower triangular and an upper triangular matrix. All right. Now, what is the use of this? That we will understand in the next class. All right. Or let me just try to explain it for you for the time being, because I still have some time. So, let me do that. All right. So, suppose I am looking at the system A is equal to, or I am looking at the system Ax is equal to B, and I know that A is n cross n, and I am able to write A as LU. Fine. I am able to do that. So, LU exists. So, I am able to write A as lower and upper triangular. Fine. So, I can rewrite this part as LU of x is equal to B. Fine. So, let us solve. So, let us solve Ly is equal to B. Now, I know that L is lower triangular. So, it means that L looks like, some say, let me write L11 0 0, L21 L22 0, and so on, Ln1 Ln2 Lnn times y1 y2 yn is equal to B1, B2, Bn. All right, I started with an n cross n matrix, therefore, everything is in this form. So, if you see this Ly equal to B, then I know that y1 is equal to B1 upon L11. All right. Similarly, L22 y2 plus L21 y1 is equal to B2 will imply that L22 y2 is equal to B2 minus L21 into y1. Y1 is already known, B1 upon L11, and this will imply that y2 is equal to 1 upon L22 times this. All right. So, what we are saying here is that I am able to find the solution of this. So, able to find a solution of this system. Now, why am I able to find it out? So, please understand that in the previous slide or wherever we had done this system of equations, try to solve it, the idea was that these matrices had the property that these entries were 1, 1, 1, 1, 1. They were never 0. They were the diagonal entries and we did not play with them. Fine. Here also, if you look at by induction, you can say that the diagonal entries of L tilde are 0. Again, I have put a 1 here. So, again I have something in the diagonal which are all 1s. All right. Since they are all 1s, this system can always be solved. So, I have a solution here for us. Is that okay? Fine. Once I have a solution here, let us look at this. So, I am assuming that. So, why? So, let y not be a solution of Ly is equal to B. Once I know, and which is very easy to solve, we are just solving it by back substitution or something like that. Fine, you are just solving it here. So, I go back to this equation now, which was nothing but Ax is equal to B itself. So, I have been able to solve Ly is equal to B. So, Ly is equal to B means B is already got. Fine. And this is the one that I am looking at y, isn't it? So, if you look at, if I write, so write Ux is equal to y, then what we see here is that L times Ux is equal to L times y, which is B. At the same time, this is also equal to Lu times x, which is equal to Ax. Fine. So, indirectly I am solving the system Ax is equal to B. Fine. Now, if I want to solve now, so now need to solve Ux is equal to y naught because already obtained y naught. Fine. So, again U is upper triangular. So, U has this nice form which is U11, U12, U1n, 0, U22, U2n, and so on till UNN times this x1, x2, xn is equal to y naught of 1, y naught of 2, y naught of n. Fine. From here, if you see this part, I get that xn is equal to y naught of n upon unn. At the next stage, this entry at the next stage, if I look at, I can compute, I can use this idea un minus 1, n minus 1 to get the value of xn minus 1 can be obtained using the n minus 1th row of u and so on. So, I can build up on this idea to solve the whole system. The important thing here is that it may take time for us to solve this, to get the lower and upper triangular form of A, writing A as Lu, but once you have got L and U, it is very easy to solve it. All right. It turns out that the MATLAB package or any package that you are looking at, they basically try to write the matrix A in terms of Lu, but since there are condition that you need. So, they do not look at A equal to LU, but they look at what are called writing A is equal to sometimes LDU, or sometimes they try to write A as PLDU, where P is a permutation matrix. So, I have not done permutation matrix, I am not bothered about for the time being, but the idea is that when you solve a system of equation, you are allowed to interchange equations. Your first equation can become third equation can become second equation, and so on, fine. So, this permutation matrix, it changes the, see, look at this, I am writing P on the left, and therefore, what we are doing is that we are trying to interchange the equations or the rows of the matrix A, so that the matrix that I have is in nice form, what is called a regular form, and for the new matrix I can get this decomposition A equal to LU. Is that okay? So, there are some questions in the assignment sheet related with LU, just try to solve it and do not worry about the exam. Maybe I will have maximum one question, or you need to just have an understanding of the subject. That is all for the time being. Thank you.